All right, this presentation is on the prevalency of farmed fish in today's supermarket. As it states in the subtitle, it's a presentation on the invention, development, and future of the process of raising marine and freshwater species for food. It was created by me, Augustus Pendergrass, for Food Science and Technology 260. So on this introduction slide, while the mention of aquaculture most likely evokes images of open cage fish farms, like the one pictured in the upper right, many species of crustaceans and mollusks can be raised artificially as well. You'd be forgiven if you thought aquaculture was a modern innovation, but carp was actually kept in ancient China, and the ancient Romans actually kept oysters in oyster farms, and they had indoor vivaria that they kept fish fresh before they were eaten. Uh, Obviously, there are many contemporary concerns about the ecological impacts and sustainability of farmed fish, and I'm sure you might have seen bumper stickers like the one pictured in the bottom right. And so these concerns are definitely within, the public awareness. So as evidenced by this chart on the left, that I've gotten the data from the UN Food and Agricultural Organization, also known as the FAO. So we can see that the consumption of fish and seafood has been rising in popularity for the past half century. And while this data in this chart only shows that increased consumption in the United States, this is definitely a global trend. So natural fisheries are unable to keep up with this increasing demand, and as a result, they will collapse. We recently studied this phenomena in this course when we were looking at the sardine fishery off the coast of Monterey, California. In 2014, the FAO recorded that more farmed than wild-caught seafood was consumed, and this is the first time it's happened in recorded human history. And this is most likely a trend that we will continue to see continue on. So the earliest recorded form of aquaculture is described taking place during the Zhou dynasty. I hope I'm saying that correctly, in ancient China. They have also been recorded as the first polyculturalists, and from my research, they would take the byproducts from agricultural facilities or livestock being raised, and they would feed that to carp kept in ponds. It was pond aquaculture, and then later these ponds could be drained, and the now fertile soil could be used to raise crops. The ancient Romans were pretty famous for their love of oysters, and they developed a way to raise them artificially, as opposed to fishing for them wild caught. And they also were known to keep fish alive indoors in modified Assyrian Bavaria. And there are records of guests being allowed to pick out the fish that they would consume that evening. And then also mussel farming was practiced in medieval Europe, but the harvest bounty was only for that upper class, so mostly nobility. We wouldn't see the prevalency of seafood being offered to the common masses until much later in history. So some contemporary technologies and innovations that had to happen or be developed for modern aquaculture is as European waterways became polluted and overfished. This resulted in the need for artificial reproduction of salmonids, and they mostly focused on rainbow trout. Prior to the invention of artificial granulated fish food, agriculturalists relied on byproducts from meat processing facilities, like I mentioned before in ancient China. The problem with this is that the food is highly variable in nutrition, and an alternative that is, highly uniform and cheap allows these aquaculture processes to be scaled up. Water quality and disease are major concerns when large numbers of aquatic animals are kept in confined spaces. So advancements in chemistry led to the development of water stabilizers that help keep various chemical contents in the water like stable, and they allow the fish to continue living in this confined space. And then advances in microbiology led to the advent of antibiotics. So to elaborate more on some of those scientific principles, uh, obviously the ancient Romans came way before the work of Pasteur, as we learned in this class. So they didn't really understand germ theory, but they did understand how quickly seafood would spoil as soon as it was caught and killed. This is like a really big concern when you're consuming oysters, and that's usually why they're kept alive until right before they're eaten, and then they're eaten raw. And this is all to combat spoilage and food poisoning. And so the underlying concepts and techniques of the artificial breeding of trout were first pioneered by this guy on the left, Stefan Jacobi. He was a German in the 1700s who took an interest in collecting eggs and hilt from trout and then artificially breeding them. Later in the 1920s, Nicholas Fleming famously discovered that certain mold was able to kill, bacteria colonies, and from that he was able to artificially synthesize penicillin. And without his work, we wouldn't have the modern antibiotics that are so widely used in aquaculture facilities today. And so there's some other foods that utilize similar technologies. Most notably are feedlots. They're also known as concentrated animal feeding operations. I'm sure you've seen some imagery like the picture on the right of some of these facilities. And similar to aquaculture facilities, when you're keeping this high of a concentration of animals in such a small space, there can be large environmental impacts. There's lots of solid and liquid waste produced, as well as the medicines, antibiotics, supplemental nutrients that are added to the food. They're not all consumed. And so this is also found in the neighboring like water supply as it makes its way out of the facility into the surrounding environment. And so along with the ecological impact like of the areas surrounding these facilities, there are also big issues with contagious diseases. And a lot of times these facilities aren't maintained to the standard that they probably should be. And instead, widespread use of antibiotics and antiseptics sort of are substituted. And this is also not sustainable environmentally. And so taking a look at the broader perspective of what aquaculture, farmed fish, and feedlots have had an effect on our society. So historically, only the wealthiest of individuals could consume seafood unless you were living in like a seaside community. This has definitely changed in more recent decades. We have products like the Filet-O-Fish from McDonald's. So you can see that seafood has become quite ubiquitous, and farmed fish has had a huge impact in lowering the cost of seafood. And so you have in the media recent coverage on disease outbreaks such as mad cow disease. And like I said, you've probably seen sensational footage or media from feedlots or maybe some those open cage fish farms. And so this imagery has led to an increased public, awareness of how their food is produced and the conditions that the livestock is raised in. And then that in turn has resulted in a push for more humanely and sustainably produced meat and seafood. Looking on at the pictures on the left, I'm sure you've seen pictures on beefs, stickers on beef stating that's been grass-fed. You've seen the stickers on seafood stating that's been wild caught. So almost in this pendulum swing back towards wild caught seafood appearing more environmentally friendly. It's interesting to see that first. I think a lot of people thought that farmed fish, was the savior for our national fisheries, and now we're seeing that a lot of these practices are actually resulting in damage to our waterways. So we'll have to like tackle that in the future. And speaking of the future, some of the future developments in the realm of aquaculture are this move away from those open cage fish farms, just because they typically are stationary, and all of the solid and liquid waste from these facilities, these fish farms, are just left to filter into the surrounding waterway. So to combat this, several large indoor aquaculture facilities have been proposed, and they make use of a recirculating aquaculture system, or RAS. The main advantage to this system is that water, about 90% of the water used in the facility is recycled, filtered, and then reused. So you're not constantly depleting that watershed's water supply to refill these tanks continuously. And one of my personal interests is aquaculture in space. So as we look to establish a lunar colony or potentially a colony on Mars, it would be a huge advantage if those astronauts were able to raise their own livestock. Traditional livestock is going to be very hard to do, but species like tilapia show great promise in their feasibility of keeping them on like space stations, or potentially extraplanetary colonies. So in conclusion, modern aquaculture spans a huge spectrum of types of facilities. You can have pond aquaculture that is, largely unchanged from the times of ancient China, to, like I said, those new closed containment systems. If you remember the picture on the previous slide of a very high-tech looking facility. And there's everything in between. I didn't even show pictures of shrimp farms in Africa, or other sort of inland facilities that are not completely contained, but are not open water facilities either. And there is no clear answer as to whether these new techniques are completely environmentally friendly like they tout to be, or if they're completely sustainable. And I think it will take several decades of research and data to really determine that answer. And looking at the trend of the past several decades, I think we will continue to see an increase in the amount of salt and freshwater species that we are consuming. And the only way I think to offset that consumption is through aquaculture. So if we want to keep on seeing farmed fish in our supermarkets, I think there's a lot of work to be done on the refinement of these new sustainable aquaculture techniques. And I will pause just a second on this last slide in case you want to review any of my references. There's a lot of information there, and a lot of it is very specific to a certain chemical or process or species, but a lot of good information there. But thank you for reviewing my presentation, and I hope it was informative.